Sing a nursery rhyme.
Mary had a little lamb. Her fleece was white as snow. And everywhere that Mary went, her lamb was sure to go. I had to dig deep for that one. Hi, my name's Sam Bledsoe. I grew up in this area in Rockingham, Vermont, and went to school in Bellows Falls. And then 6 years ago, I moved down to Coatesville, Pennsylvania, which is about 40 minutes outside of Philadelphia. While there, I worked at a mushroom spawn company, and we created mushroom substrate for Agaricus bisporus, which you guys would know as either the white mushrooms you can buy in the store or portobellas, the big brown portobello mushrooms. That was the main crop we grew to make money, but at the moment, with fungus and mushrooms in the industrial world, there is a growing number of uses for fungus. And so we did a bit about that. And we did a bit with other types of funguses. I can't talk much about the funguses we actually worked with because I did have to sign a bunch of confidentiality waivers for it. What I can talk about is some of the other types of funguses that are out there. Because whenever I want to talk about fungus in the US with Americans, mostly people just want to talk about psychedelic mushrooms. Or the other big one that everybody wants to hear about is the funguses that grow in your bathtub and are bad for you and could possibly kill you due to the spores being released. So there doesn't seem to be a lot known about mushrooms and fungus in general. Even though there has been many uses of mushrooms and fungus in industry throughout the world, throughout history. The earliest example I can come up with is Saccharomyces cerevisiae, also known as brewer's yeast, ale yeast, bread yeast. It's the yeast that's used mainly to produce beer and bread. Even though the first use of it dates back to about 7,000 years ago in Mesopotamia, it wasn't until Louis Pasteur and the more knowledge about microbiology that we're able to sort of pin down what it was. And then from there, we were able to create more strands and breed it for more specific purposes. It was domesticated for wine and beer, as I said, and in that case, it's really good at breaking down carbohydrates or sugar and turning it into alcohol. But the breeding for bread sort of ignores the alcohol production stage of it and focuses more on its CO2 production. So the other big earliest one that sort of kick-started the microbiological revolution in the 20th century is Penicillium Chrysogenium. It was discovered in 1928. They were doing studies on a type of staph bacteria. When somebody accidentally left the window open, mold spores came in, landed on the petri dish. At first they were annoyed, but then they started noticing that the staph was actually dead and dying, and decided to look deeper and deeper into it, and finally full-scale production began in 1940. If you want some fun reading material for scientific papers, there's a lot of interesting ones that were produced in the 1960s after full-scale production had been going for a while, and a lot of scientists were standing around, saw how much of the mold was left over after they extracted the penicillin from it, and said, what are we going to do with this stuff? And wrote these very, very, very optimistic papers on the other uses for leftover mold. My favorite was using it for cattle food. The other big one for penicillin is that one also it goes back much, much earlier to about 50 AD or 50 CE, depending on how scientific you are. And more importantly, it was known as Penicillium roqueforti, and it's used in cheese production. The most famous one being blue cheese, but any cheese that uses mold uses penicillin for it. The next big one that we encounter about the 1980s is Trichoderma Risii. This one is fun if you grow mushrooms. If you grow mushrooms at all, Trichoderma is very, very, very bad. It's a green mold that will grow over your mushroom bed and actually start to attack and destroy the agaricus mushroom. But it's that property that actually makes it really useful for industry, because it creates an enzyme called cellulase. And cellulase is an enzyme that breaks down cellulose. So one of its earlier industrial uses in about the 1980s or so was used in acid wash jeans. Don't know how many people either own a pair or used to own a pair. And now cellulase is used a lot in if you buy bio-friendly dish or clothes detergent. There's a lot of cellulase derived from fungus that exists in there. And then in agriculture, it's used for fungal control, because as I said, it also likes to really help break down a lot of funguses as well. So if there's any problems that you have with fungus in your crops, you can usually get some spores saturated in a solution, spread it over your crops, and it helps break down any sort of molds that might be dangerous to your crops. In the same vein, there's Trechoderma Herzerium, which is found in the soil. Its main property is that it's a mycorrhizal fungus that grows along the roots of a lot of different plants, notably corn, and helps draw nutrients into the plant itself and helps provide a nice, bigger and healthier crop by nitrogen fixing, helping with calcium uptake, and just allows optimized nutrient exchange. This goes back into my dangerous molds, though. There was a study done probably back in the mid-2000s or so on houses damaged by floods, where they studied the trichoderma that was growing in there and found that Trechoderma Herzerium is harmful to boar sperm, but they haven't actually found any effect on human sperm at the moment. We've got Rhizopus Stellonifer, which people here might know as the black bread mold. So when you have a piece of bread, you leave it out on your counter and it grows that nice black mold on it. You get Rhizopus Stellonifer. And what's the fun, important thing about that is that its enzymes are used for birth control pills. Mainly, it activates hormone controlling steroids that help break down progesterone, which is the steroid used in the menstrual cycle and pregnancy. We got two more here. You got Aspergillus Niger. The Aspergillus ones are are another powerhouse because of just the wide ranges that they can create. The big one that it does is it can help create citric acid. So if you need large quantities of citric acid, that it's mostly being sort of derived from Aspergillus. It also creates 3 different types of enzymes, like lipase, which breaks down lipids, proteases, which break down proteins. It also produces cellulase as well. So anything that you need to break down proteins with, you can use it for. If you need it for, as I said, citric acid, it can be used for that. And just for breaking down other different structures for more use. As a sub thing, I've got Aspergillus Risii, which is used in soy sauce production. The biggest thing that people have been using fungus and bacteria for the past 7,000 years, we'll say, has been in the process for fermentation of food. You live in an area where your water sources aren't that great, and so you need something to sort of make sure that, the water's safe to drink. Well, a lot of times you just sort of have maybe water contaminated with one of these many different types of yeast and molds, and suddenly you didn't die when you drank it. And it was found, and a lot of the stuff's found too, to make something that was previously unedible suddenly edible. So sort of like with soybeans, that you could use Aspergillus Risii to help break down the shells and structures and sort of help bring this nutrients that were available in soy and make that available to people to use. And that's what I've got for the big different types of molds. It's also being used for a lot of the organic pesticides, herbicides, insecticides, any of those things that are used in agriculture, in organic agriculture. A lot of that stuff is being derived from fungus today. That's where the big market is at the moment, is mostly in agriculture, and that's where you're seeing a lot of the stuff being used today.